Good evening, young ladies and old men. This is Manuel, Delta Lima 2 Mike Alpha November. Welcome back to my channel. This episode is going to be a special one because after Kevin's experience with the original uSDX rig bought from the only approved supplier, I thought I'd have another look into that. So I asked to send from the current series, I asked to receive a completed rig. Today what I'm going to do is I'm going to unpack that. The box is still sealed. We will unpack that together. Be prepared, this is going to be a long video because there will be no cut except for after this intro and after everything has been done, the outro. This will be a long video. I'm going to unbox that. I'm going to do all my measurements that I would normally do. I'm going to disassemble it, have a detailed look inside. So we will see what the quality is out of the box. We want to make sure with the approval procedure that you, the customer, gets the quality that we, the designers, want it to be. Okay, let's start. Okay, there we go. I just covered the private information. Except for that, the package is sealed. Now, let's cut here. Let's cut here. It's like Christmas. Okay. Good. So she sent me, she already announced that, another classical band boards and high band boards, including accessory packs. That will be another video, or at least another test. This is the new batch. I need to build that, test that, and approve that. This is going to be another video, and we have 1, 2 uSDXs. She sent it with cables. I'm going to put them in the box because I don't need them on my bench here. Okay, let's see. I hope everything is viewable for you. Yes, it seems. So, first impression, it's really good protected for transport. Well, if in doubt, use a knife. Okay. So, in case you never saw that before, what Sunny does is she writes the serial number of your rig on here. So always keep that back, or at least write that down and put it onto a sticker on the bottom. Same here. Now, let's have a look. And I'm going to write that down. Orange. Green. Okay. Now, actually, this is the first time I see a print by Sunny. And I must say, she does do a really good job. Nothing to complain. Even the The lettering, which many people seem to struggle with, is of decent quality. I can't complain anything. The green one has a special nice touch because the black lettering is inside, underneath the surface. Okay, ready for the smoke test? This is my power supply, my workbench power supply, 12 volt, limited current, so in case there is a short, it won't probably go up into smoke. I always put the dummy load on there, just do a short check before connecting anything. Looking good. Okay, here we go. Zack, and voltage is breaking down because my limitation is 2. Okay, there we go. Oh, it has even my call sign. Look at that. Good. Okay. Now, what I always do is put S meter to S, forward SWR. In this case, we want to see efficiency. Putting it to CW. Okay, there we go. 600 milliamps. I'm going to write that down. Green RX 0.08 amps, TX 0.6 amps, by the way, that was 80 meter. Now I'm going to measure output power. I do that by using my oscilloscope. Okay. Oh, that's not much. What's going on here? .6 volt peak. Do I have a problem here? That doesn't look right. Not a good start. 21.8 volt peak. 21.8 volt peak. Okay, now let's check 40 meters. 23.2. What's going on? Let me check if there's a problem with the probe. I'm going to switch the channel real quick. No, actually, I can confirm this. This is interesting. Very low output power. Why is that? You know what? I'm going to increase voltage, current limitation a little bit. I'm going to reset the rig before I do anything. Going to reset settings. This meter set to S. here we want to see power and efficiency. Oh, okay, now something was not working. I'm going to switch back to the original channel 1 because I have a trigger point there. Nope. It's 10x, 10x. Ah, there we go. Okay, my fault. The dummy load's bad. It has a little bit of contact problems because, as you can see, it's quite used. I probably need to send Hans a little bit of money and buy another one. Yeah, okay. Now that's looking completely different. Let me check this. Yeah, that's actually quite impressive. 48 volts. RX, TX, VPP. What did I say? 48 it was. 48 volts, yes. 48 volt, peak. RX 0.81, TX 0.665. We're going to repeat that real quick for 80 meters. $45.6. See, usually this would be cut out because yeah, it's a humiliating mistake. But this happens. I wouldn't publish something like that because I always question myself. I always question my measurements, my measurement methods, and I'm double and triple checking before saying something like, yeah, it is that way, you know. The next step would be that I would have confirmed that measurement with my power meter. So I would be really sure that it is actually the way my oscilloscope is indicating. But it's not the case, yeah. Let me see, I need to change the time base real quick because we are already on a higher frequency now. Okay, so 49.2 volts. (49.2) 20 meter. Receive 0.84. TX 0.767. Okay. Now, what did it read? Yeah, 5.9 watt, and 70% was the display reading. 5.03, 77%. 5.03, 77%. And 6.02, 77% efficiency. You're probably wondering why I'm not freaking out. I don't give a beep about the display at this point. I'm going to show you what I'm doing. I'm going to grab my tablet. So I have a real big calculator for you to see. I'm going to calculate the real efficiency, and then I'm adjusting our shunt in the menu so the values that are shown in the display match the reality. That's the deal. The problem with an uncut video is now I have to yeah, you have to wait until stuff happens. Okay. I hope I'm not getting embarrassing mails to prevent that. I'm going to switch off Wi-Fi. Let me check if you can see that. Not really. Okay. Check again. Yeah, the lamp is quite annoying here. I'm trying to switch that off. Yeah, now you can see. Excuse me, I'm going to switch it on later. So, what do we have here? We have 0.6 amps minus 0.08 amps times 12 volt, 6.24 watts in. Then we have 45.6 squared divided by 400, 5.1984 watts out, divided by 6.24, 83.3% efficiency. Next one is 40 meters. This is 0.665. Do you see that? Yeah, probably 0.665 minus 0.081 times 12, 7.008 in. Then we have 48 volt squared divided by 400, 5.76 watts out, divided by 7. I can't read my own claw. 7.008, I think it was. 82% efficiency. Now, okay, I don't know why I switched now to the 20 meter bands. The measurements are done. 0.767 minus 0.084. 0.683 times 12. 8 watts in. Wow. 8.196 in. Then we have 49.2 squared divided by 400. 6.05 out divided by 8.196, 73.8% efficiency. Okay. Now, what I'm going to do, yeah, that's interesting. We are pretty close on 20 meters. Yeah, let's see. I'm going to adjust now the efficiency readings for the 20 meter band, and we will see what the 70, that was too much. We will see what the reading will be. 73.5, that's close enough. 6 watts out, that's also close enough. So you see what I did? I adjusted menu point 8.6 are shunt, so the reading, the values that I read out match the reality. This is a little bit different from lot to lot because the shunt resistance is depending on PCB trays, and depending on what the factory does, how their chemistry is working, this varies a little bit. So we gave you the opportunity to adjust that to match reality. Now let's see what our R shunt 18 does on 80 meter bands. We are now on 81. In reality we have 83. Okay. 81, 82, 82. Yeah, that's close enough. That's close enough. I would be satisfied with that because it's no precision instrument, but we are now very close to reality. That's the very first thing I did. The next thing is, what are the specifications? We specified that there's minimum 4 watts out at 12 volts. We are at 12 volt. We have matched that minimum 4 watts out. The problem is the other specification is maximum 6 watts out at 13.8 volts. I don't think we will do that because we are already over there. So I'm complaining about too much power. Get it? But it's part of the specs. So I would normally say, hey, take care of this, but it is, yeah, what should I say? It's actually already in the ballpark, what we are seeing here. They did a great job. Normally nobody complains about max power, but according to the rules, this would be out of specs already. Yeah. Now let's see the different requirements. We want to check. Yeah, let's check receiver sensitivity and harmonic suppression. I think I don't have my attenuators here. I have an adjustable attenuator. We can at least test receiver sensitivity. Oh, that's the wrong one. That's the right one. Up to 120 decibels. For this measurement, I'm putting the rig to practice mode. See? So I don't accidentally transmit into my tiny SA. That would be a bummer. I probably should pick up an external speaker. Mode low out. We are at 7.03. The thing is, I didn't yet calibrate the frequency, so we are probably going to be a little bit off here. Let's see, setting the level to -50. And okay, that's center frequency. See, this is a S9 plus 10 signal. I'm going to change S meter again to dBm. -60 dBm. And just to make you aware of that, that's level -50 dBm. This one is set to 10 dB. I hope you can see that. Yeah. So the measurement's quite accurate. 10 dB down. Let's see until it settles. Now it settles on -70. Perfect. 10 dB down. 76, 80, perfect. Minus 91 dBm. Minus 100 dBm. Now I need my external speaker in order to hear that. I said it would be uncut, but I can still hear it now at minus 110 dB. Sorry, minus 110 dBm. And minus 120 it's gone. So that's the, yeah, it's still barely audible. So the receiver sensitivity seems to be okay. Barely audible. Can you hear that? I'm going to switch it off so you will hear the difference. Did you hear that? Okay, at minus 120 dBm it's still audible in the noise floor, even though the S meter is no longer accurate, as you can see. That's one thing. Now we want to check sideband suppression as long as we are already here. So I'm going to switch to LSB or USB, it doesn't matter. Then look for the frequency. What is it? Minus 80. Okay, that's it. Minus 80 dBm. Let's increase that a little bit. Minus 60. So I changed sideband. Minus 60. Minus 60. Minus 99. So we have almost 40 dB of sideband suppression. That's completely sufficient for this kind of rig. Okay, did you see what I did here? I injected a signal very strong, tuned in on one sideband, switched sideband, and see how that changed here, the behavior. It's still audible, yes, but that's the level of sideband suppression we have here. And just to mention that, I think this would be now a S9 plus 20 dB signal injected here. Okay. What's next? Yeah, usually I would look for harmonic suppression. Let's see how we can do that here. Let's see what we can do here. I need my big fat dummy hose. Where is that? Yeah, there it is. Okay. I'm going to transmit into that. That's a 40 dB attenuator. This one can handle power, and after that I don't need power anymore. I'm going to go inside there. So I need another set of cables. I saw one here. By the way, what you're hearing is my chair that's moaning under my weight. Okay, so we are going in from the true uSDX into the big dummy load. We are coming from the tap into the adjustable attenuator. And from there into the tiny SA. Now, I'm going into spectrum analyzer mode. I'm leaving practice mode. Practice, there it was. Now I can transmit. Just double check here into the big dummy load, from there into the smaller dummy load, from there into the, yeah, okay. So let's see. Let's start at 80 meters. I didn't use it in a while. Measure harmonic. So I'm entering fundamental 3.56 megahertz. Now I'm going to transmit. Watch for decent what's the fundamental? What was the minimum or maximum rating? I'm not sure anymore. I think we were in the range of 60 dB. Something's not right here as well, as this is not showing me good SWR. How come? This is not okay. Is there a problem with the cable? No. Okay. See? Now I have good SWR. I hope you can see that. There was something with the cable. We have a right measurement. Now we have minus 21.8 dBm first, 50 dB second harmonic, 53 dB, minus 50, minus 53, minus 70. Perfect attenuation. I'm going to attenuate that further down. That's already too weak here. Same thing. Okay. So 80 meter harmonic suppression is sufficient. Remember, we need to be below minus 43 dB for every band. Now let's go to 60 meter. Measure harmonic 5.3515 megahertz. Again, something not right. There's some bad connection on the cable. Something is not right here with my setup. There we go. This is the bad one. See? Yeah, this is the bad one. But right now it's looking good. Minus 10 dBm, 45 dB, and 53 dB. I think I need to attenuate more. Minus 20 dBm. Let's increase one more. Minus 30, minus 45, minus 52. So also perfect result. 7 megahertz. Measure harmonic 7.03 megahertz. I'm going to push that down this time. Minus 30 dBm fundamental, minus 50 dB, minus 48 dB, minus 47 dB. So also okay, right out of the box. You see, just to remind you, uncut here. Frequency, sorry. Measure harmonic 10.106. Measure harmonic 10.106 megahertz. Yeah, that looks better. Fundamental minus 30 dBm, second minus 45 dB, 46, third minus 44, fourth minus 51. So also within specs. Now let's go for 20 meter, measure harmonic 14.06 megahertz. That doesn't look good. No, that's not good. What's going on here? Minus 30 dBm fundamental, minus 28 second harmonic, minus 32 third harmonic, minus 44 fourth harmonic. Let me see. No, unchanged. So this rig does do a little bit of harmonics on the highest band on 20 meter. So I need to adjust the second harmonic notch on this one. But that's what we get out of the box. From a measurement perspective, that's what we get. So it does make sense indeed to check that and to adjust that. All I did was using a tiny SA, attenuators, oscilloscope. Okay, I know most of you don't have that, but I didn't ask for something specially tweaked here. I asked for something from stock that she would send a customer. So we got a real picture here and not something, hey, DL2MAN gets it, do something special. Going to I'm sorry, this was not me. We reached maximum recording time. It stopped. I'm still in the process of cleaning up here. And I'm going to show you the guts of this thing. So we can see, maybe I'll bring the camera a little bit down anyway, so we have a little bit more detail. Good. Let's see. I'm glad we completed all the measurements without any cut, so okay. Let's start with the bottom. Well, first of all, I'm going to remove the audio adapter. Sorry, PNC adapter. I'm pulling the knob. I just realized it was out of focus. I'm sorry, but you didn't miss anything. I just removed this stuff. Okay, let's see. By the way, I wanted to address while I'm opening this, I wanted to address this high power thing. Why I would reject that, that's because we lose safety margin for the PA. I mean, if you really have perfectly matched BS170s, it doesn't matter. They will handle that. But I don't ask for trouble. It's just, this was designed for 5 watts. If you are doing already, what did we have? 6 watts at 12 volts. Now somebody's using lithium battery and injecting 14 volts or something like that, and suddenly you're in the 7-8 watts range, and you're asking a lot from the poor little BS170s. Okay. What I can see already, let me see if I can zoom in for you. They didn't clean the flux. Can you see this? They didn't clean the flux. That's also something Kevin mentioned. That's not very good. What is that? Looks like super glue. This looks strange because it's milky. That's usually a sign that somebody used super glue and just left it there. Pretty nice housing still. Yeah. They cleaned flux, but not very good. See this? Let me see if I can put the lamp here a little bit more. Sorry for the flickering. Yeah, there is flux here, everywhere flux. But opposite to Kevin, I cannot see any. Okay, probably I should look at the soldering side. Yeah, there they did. You can see they did a cleaning job. Not very good one. We have this aggressive cutting Kevin was talking about. At least I don't have cold solder joints, but I can see this aggressive cutting. And I can see, yeah. Oh, look at that. Can you see that? There is tiny bits of solder. Sonny, why? I mean, it's working. The rest of the job is flawlessly, but there was even here, you can see cleaning attempts have been made. There's, see this? You can see that. The remains of tissue they used. But it's not a very good cleaning job. If you look up close like me right now, you still have remaining flux. See that? I wouldn't take care about this at all if I would have soldered that. I need to be fair here. If you, it just can show you in comparison the thing that I soldered, which looks way worse. Yeah, look at that. No cleaning at all. So I wouldn't necessarily complain about that. But we had the situation where Kevin received the thing, had a problem with that, and could track it down to bad soldering and to yeah, actually bad soldering plus minus a little bit. So I wanted to have a look at the work they are doing. It's not looking too bad, but also it could be more beautiful. Sonny, if you hear that, please take care of that. This needs to be addressed. I thought we talked about that. That shouldn't look like that, you know? If you do it, don't waste the time. Do it thoroughly, do it completely. Then it's good. But as you saw, out of the box, it worked. So I won't complain. Actually, I do complain because I did expect more. I did expect that they were more careful. Okay, so let me put this aside in an empty box. I'm going to put it in here. I will assemble it later. Now we will have a quick look, only a smoke test basically, of the other rig she sent me. I'm not going to have an in-depth look, because this video would be hours then. Just make sure everything's completed. There's one screw. All the housing parts. Yeah. Now, let's have a look. Back to the dummy load. Smoke test. I'm going to limit current again. Okay. Okay, this one is out of the box, better, interesting. This one was also on CW. I never switched it on. Usually when you get the rig new, it is on SSB, or if you reset it. So this one seems to be, they have tested it obviously a little bit more, or did some more checkings, I don't know. Yeah, this one is out of the box at, according to this, 86% efficiency. 84, 85, okay, we are already collapsing current here. But this is also looking, yeah, 6 watt at 12 volt, this seems to be a general thing. Yeah, I made my point clear why I don't like that. 12 volt, already 6 watts. This should be addressed by compressing windings. I'm sure if I would make a poll and ask you if you would like to have that addressed, you would say no, because everybody wants more power. However, QRP is usually 5 watts CW and maximum 10 watts SSB. For you SSB guys, that might not be a bad thing. You're also not running the PA at 100% duty cycle, so probably get away with much more, but it is out of specs. I'm the children that jumps on the floor. Ma, don't like that, mommy. No. Okay, so it's transmitting on all bands. Wait a minute. No, that's the orange one. Yeah, I'm not using this kind of screw, so that was not one lying around by me. I need to make sure, you know. That would be a bummer. Okay, no, I'm not too disappointed, but I'm also not too happy, to be honest with you. This is actually pretty okay. If you receive such a rig, you don't do anything wrong, except for the fact that we have bad harmonic suppression on 20 meters, at least on the green one. We should address that. So it's still not, it's not a rig that you could just send to the FCC and say, here, remember, this is a project that's meant to be built at home by hams that know what they do. And in this case, you're not buying a completed commercial rig. You're actually paying someone to build that rig for you. You gotta have that in mind when buying such a project, okay? So still there needs to be taken some special care to adjust that. I'm sure it can be adjusted. The main thing here is what I look really carefully in. Can we achieve efficiency with the hardware provided? Because I know I can tweak any board anywhere if just the basic parts that they used are good enough so it can be achieved, you know? That's the main goal here. So the basic hardware is absolutely okay. Sunny does a great job. Also, I'm really impressed. I never saw a print job by her, but because I never asked for a housing, obviously. I have a printer, I designed that, I know how that's supposed to look. But it's actually impressive to see that she does a really good job here as well. So you get a decent housing. That's really good. I love that. Yeah. And there it cut out again, this time because of storage. I needed to remove stuff from my phone so I could record further. I talked for like additional 15 minutes before I realized what was happening. So I'm jumping direct to the outro. What's the takeaway from this? In general, they work. Out of the box, as I could see, there is room for improvement. Sunny, I would really like to ask you to address that. I'm not withdrawing the approval because the overall picture is still good. And you still need to remember, this is not a commercial rig, right? She does a great overall job. The majority of rigs work as intended. A little bit of tweaking might be required. I cannot ask her to do that because, yeah, then the price probably would double. Imagine how long I took for just the basic measurements. Today it's like, I think when I look at the video, it's about 30 minutes plus. And imagine on top of that, adjusting the rig for best efficiency and so on. There would be another hour of human work on there, and you wouldn't be willing to pay that, I assume. Maybe we can talk to her and say there will be like really tuned and tested versions for more money for people of I don't know, I'm just talking into the blue here. So I'm ending this video with a little bit of mixed feelings, because on the one side it's out of the box, it's working, but there are issues, okay? Especially considering that we had these issues with Kevin, that realized that his rig didn't work because of bad soldering jobs. I saw parts of those here as well. I'm not happy about that, I can tell you. I will talk to Sunny, but this is obviously not something I will do in public. And yeah, so let's start with a little bit of fun. I'm suggesting a drinking game. Anytime you hear me, you watch my videos, get together with some friends, watch my videos, and every time you hear me say, "So, you need to drink," I guarantee you this will be a fun evening. See you next time, 73. Bye-bye.